Hello yet again. I decided to do one more on here, and then we're going to do some more. We're going to do some on the computer. I'm going to do the cloud example. But we need to talk about two independent samples a little bit. And we need to talk about the variance test. Okay. And for those of you that just took 3311, I kind of glossed over that because we were using R, or we were using the R commander, and they didn't really have it in there. But it's time to grow up and use it and do it right. Okay, so we've done one independent sample, and you use Z's and T's in that. Now we're going to use two independent samples, and as some of you know, all the things I know how to draw look the same, except for my ghosts. Well, they kind of look the same too. Here's my ghost. Okay, so now what you're going to do, essentially, that's a population, not a population. You're going to sample from two different populations, two independent populations, and get your inference based on those rather than just one. Okay? And let's talk about the setup on that first, and then we'll talk about the variance test. By the ghost is not a Pac-Man. Everybody says he is, but he's not. Okay. So when we set up the hypothesis test, let's talk about that a little bit too. Step one, again, you're going to have the three-step sort of thing, but there's going to be a slight difference. You're going to have mu1 less than or equal to mu sub 2 versus mu1 greater than mu sub 2. Okay, in the second case, you'll have HO mu sub 1 greater than or equal to mu sub 2 versus H1 mu less than mu sub 2. And then, of course, the third one is equals, not equals. And the same kind of wording comes into effect here. The only thing is you'll see it's more going to be test the claim that the mean of the first group is equal to that of the second group, or test the claim that the mean of the second group, or excuse me, the mean of the first group is less than that of the second group. You always make the first group always goes to the left, second group always goes to the right. Okay, same wording, same kind of setup, and you always have populations rather than numbers. You know, in the one population, you always have a number on the right-hand side. Here you have just populations on either side. Okay, now I'd be just terribly disappointed, but we're going to start using the computer all the time, so you won't have to be doing stuff by hand in these, and we're going to be generating something called a p-value, and that's going to be your test statistic. Your third step, and this is very interesting, if the p-value that you obtain in the second step is less than your alpha, then we reject HO. We reject HO. And of course you have your conclusion. As I'm fond of saying, and most of you know this, puppies and kittens can learn how to put data into the computer and do all the steps, but step 4 has to be done by a human. And yes, my dog can, by the way. All of my dogs could. All right. So this is the basic kind of process. Now, let's talk about this variance test thing. Okay, first of all, we have independent samples. What does that mean? Okay, so if I were in a regular face-to-face class and I didn't have a bunch of brothers and sisters in my class, and I said, guys, stand on the left-hand side, girls, stand on the right-hand side, that would be an independent sample. Okay? So there's not typically a relationship between the people in the classroom, and particularly on the first day. Therefore, it's okay to just separate them without prior knowledge. Okay? So that's what we're doing there. And we'll talk later about dependent samples, so not to worry, we're not going to neglect them. They'll have their turn too. Okay? So, we have to take one other thing into account, and that's the variance test. And you're saying, variance? Why? Because, okay. So, may I flip? Now, when we do these, you're actually putting a data set in. If you were doing these without the computer, you would have kind of a composite. You would have X1 bar and S1, and you would have N sub 1, and you would have X bar 2 and S1 and N2, where these are the sample standard deviations. Okay. Now, the variance, you want to see if those are roughly equal to each other. So you're going to have, and I'll go through the test in 1 second. You're going to generate a test statistic of S1 squared over S2 squared. And ideally, I'm going to put that in quotes, it should be 1. Oh, I can't spell. You know what I mean. Okay? If it's 1, and it can't be 0, because variance is never 0. Okay? It's always non-negative. Actually, I should say it's positive, because it's never negative. Or excuse me, it's never 0. So anyhow, and the ideal is that it is 1. All right? And when that happens, then you're saying, okay, my variances are roughly equal. So here's my hypothesis test for that. For my variances, you're going to have HO sigma 1 squared versus, or excuse me, is equal to sigma 2 squared. Why is my pen not working? Cut it out. Equals. And sigma 1 squared not equal to sigma 2 squared. And it's always equals, not equals. It's the law. If you were going to calculate it by hand, it's the F star S1 squared over S2 squared. And here again, we're going to use use the computer. So we're going to use R for that. So don't worry about it. You're going to get a p-value for that. All right. And if p is less than alpha, then you reject. And of course, step 4, our beloved step 4, the conclusion. By the way, ladies and gentlemen, make sure you're doing your hypothesis test and these beautiful 4 steps, because I tend to be pretty anal about them when I grade. I'm just weird like that. Okay? All right. So you're saying, all right, let's do our variance test, and what does this mean, and what am I going to do? Well, one of 2 things will happen, and it's going to feed into your t-test for your 2 independent samples. Okay? So let's see what happens. So let's say you reject on your variance test. So when you reject, you're saying I have unequal variances, which is actually pretty true more often than not. So what is going to happen when you do your t-tests, and you'll just set it up as like regular, when you put it into the computer, the only thing it's going to impact is when you actually put the function into the computer. You will actually skip an argument into the function itself, and you will see something different in the output. It will actually calculate something for you, and be grateful that it does. It will do a more conservative approach to the answer and to the p-value. You don't have to do anything. Okay? So don't worry about that. Now, what if you fail to reject on the variance? Okay, so what you're saying, you have equal variances. This is very nice. In the t-test, t.test, you put your stuff in, and in here you put something like var dot equals capital true, somewhere in there. Okay, and then when it does its calculations, it knows to calculate it with the true variances. It's somewhat less conservative, but you've already checked, so you know you're okay. All right, and we saw how to do the t-test by hand, and I'm going to go ahead and do the cloud thing in a minute, and you'll get to see how that all works. Okay, thanks.